Okay, now, I'm trying to give you different examples, ones that will draw out different kinds of little traps or interesting things. Here, I love this question because it shows us how mathematically you can understand something with actually very simple maths, which is totally counterintuitive. Okay, let me talk you through it. Here's a ladder, okay, and it's leaning against the wall, but it's a, I don't know, it's a slippery, wet day or something like that. And so the end of the ladder, this end, the one that's on the ground, is sliding. It's sliding at a rate of 4 meters a second, which is actually very fast, but anyway. Okay. And the ladder itself is 10 meters long.
Very few seconds.
Okay. It's just rocketing by. Okay. Now, 10 meters a second. My question is, at what rate is, this is moving along the ground. I said 4 meters a second. At what rate is the top of the ladder sliding down the wall? Okay. Now, by the way, difference between maths and physics. I'm not going to talk about forces like gravity or, like damping or friction or those kinds of things. I'm just like, it's 4. Just deal with it, okay? Now, here's what I mean by simple question, simple numbers, and simple functions, but very counterintuitive. Everything in my brain says, if this is going at 4 meters a second and it's constant, surely this is also going at 4 meters a second, and it's constant. I mean, doesn't that make sense to you? Or even if it's not 4 meters a second, surely it would be, if this is moving at a constant rate, and this 10 meters is constant, then this is also dropping at a constant rate, right? I don't know about you, that's just what, I've stared at this question for a while. I've even done all the numbers on it, and I still look and think, but how does that even work, okay? So, let's actually have a go at this and see if we can solve it. Like I said, let me say the question again. This is sliding at 4 meters a second. I'm interested in how fast this end is sliding when it's 6 meters away from the wall. Okay, 6 meters. Okay. At that particular time when it's 6 meters away, how quick is it dropping? Okay, how quick is it dropping? So, how shall we start this? What are we going to do? Time it. Watch the ladder and see how it goes, okay? What kind of information do I know from the question? What rates am I given? So I've got D, D what? Okay, so we need to actually introduce some variables in here. Let's be unoriginal and call this distance, the distance away from the wall, okay? Let's call that x meters, okay? Please note the difference, by the way, between this 6 and the x, right? The 6 is a particular value for x. X can change. I assume at some point x might have been 0. What's the domain for x? It has a domain. It can't just go anywhere. It'll be 0 to 10, right? Because once it goes splat, 10 is the furthest away it can go, right? Unless it's a self-animating ladder that just runs. Okay, anyway. So x, right? Now, I'm also asking, the question is, how is this thing dropping? So what would you suggest is a good variable for it? I suppose you could put y, because it is vertical. I'm going to put h for height, because it's high, right? So anyway, so there's h, okay? So therefore this rate that we've been given acrossways is distance over time, right? So this is dx on dt. Okay, that's the 4 meters a second. This rate here is the change in the height. So it would be dh on dt. That's what I'm after. Okay? I forgot to put a right angle in here. Okay, now, I'm after dx on dt. So by chain rule, right, I'm going to expect a dx on something times something on dt. Okay? And then you look at, sorry, wrong way around. I know x, I want h. Let's try that again. H. Is that okay? Yes? Fixed up. Now if that's what I'm trying to solve, and the information given to me in terms of dx on dt, you would look at this and think, okay, there must be an x here, and that means to get chain rule working, there must be an x there. Okay? So I know this part, it's 4, so I want to work out this. hx. There's a relationship between the two. What kind? h and x? Okay, so h and x, they're two sides of a right angle triangle, right? So I can say h squared plus x squared is equal to 10 squared because of Pythagoras. Now, this is an unusual one because, I don't have to get dx on dh. I can actually go straight to dh on dx by getting this function in the form that I want it. And it's h or x, it's just as easy, okay? So if I've got h on the top and x on the bottom, okay? Usually when you say dy on dx, right, you've got y equals blah, 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 blah. So this thing on the top, that y, was the subject. So I want h as the subject. Are you tracking with me? Is that okay? Great. So let's make h the subject. H squared is 100 minus x squared, right? And so I can just take the positive value because it's a length. Okay. Sorry, h is greater than 0. I actually can say more than that. I can say it's less than 10 as well, because that's how tall the ladder is. Because it's not an anti-gravity ladder, I assume. Because if you had an anti-gravity ladder, why would you even need it to be 10 meters? But anyway, there's my h, so now I can work out dh on dx. Okay. Now this is chain rule. This is 100 minus x squared all to the power of a half. Okay. So, do you reckon you can do it in your head? Think we can do this? We can take this guy. Okay, let's have a go. It's the power of a half, right? So what's the first thing you do? Bring the half down, so I'll multiply it by half. Okay. And then the next thing you do is reduce the power by 1. So it's going to be 100 minus x squared to the power of minus a half. Okay, so that square root's going to go on the bottom of the fraction in a second. And then, what? Multiply by the derivative of the inside, which in this case is negative 2x. Okay? So you can see this 2 and this half will cancel. And that should really be on the denominator. So I'm going to get minus x all over this. Okay, happy? Alright, so now that I've got my dh on dx, I can come over here and substitute into my chain rule part, right? That's dh on dx, I just worked it out. Dx on dt is just 4. Okay? So when I put them together, I get this. Okay? So hold on a second, let's just stop. One of the great things about questions like this when you're doing calculus is that these things have meaning, right? This is how the height is changing. And it's decreasing because the height is dropping. Sorry, not the height is dropping. The height is decreasing because the ladder is dropping. Okay? Now at this point, this is where I want to draw out the counterintuitiveness of this result. Okay? Because you can run it through 100 times. This is the derivative. Okay? This is not constant the way this is constant. In fact, it's not even close to constant. Right? As x approaches 10, think about what's happening to this. As x approaches 10, what's the numerator approaching? It's approaching negative 40, right? As this is approaching, by the way, why do I have to say approaching? Why can't I just say 10? Because I'd divide by 0. Good, thank you. Now, as it's approaching 10, what's happening to the denominator? It's getting really, really tiny, right? Because 100 minus 99, 100 minus 99.9, etc. Denominator's sort of an average number, but the numerator is like an average number, but the denominator is getting microscopic. So as x approaches 10, which is where it can end, right? dh on dt is approaching negative infinity, isn't it? It's negative because of that, right? This is not even quite, I can tell you, because I went and graphed it because I was curious. If you've got x equals 10 here, and you're graphing it with respect to height, this thing looks like this. It's dropping, right? It's not constant. It's not like 4. Okay? So, I don't know if that satisfies you. It's like, well, obviously it must be, okay? Some of you guys are going to get like a ruler and put it against the wall in a second and give it a go. But I still find this result very, very puzzling, okay? It's true, but I don't understand why exactly. Why should this be accelerating, which it is, when this isn't? How come one didn't accelerate in the other? Anyway, There's an answer to that, but I'm just going to let it sit. Now, I wanted this at a particular position, right? What position did I want it? When x is equal to 6. So the last part is just pop it in, okay? So when x is equal to 6, that derivative will be, let's see, minus 24 on the square root of 100 minus 36, which is 64. So that's minus 24 on 8, which is minus 3. Okay. So it's dropping at a rate of 3 meters per second. So you would answer that the wall end of the ladder, the top of the ladder, that would be a nice way to say it, is, and instead of saying -3, I'm going to say it's descending or dropping at. So the dropping gives me the direction, you see, at 3 meters per second when x equals 6.